So yeah, over to you, Brian. Yeah, talking about object storage and how that fits in the Kubernetes world. So over to you, Brian. Thank you.
Thank you. And thank you all for being here, for staying. And beyond that, thank you for staying awake. Right? It's Kubernetes storage. So I want to talk about an open source component of our product, which is designed to manage local storage in a Kubernetes environment, which is a challenge. But I need to set some background first. So I come from MinIO, and you may be familiar with it. MinIO is a 100% drop-in replacement for Amazon S3, and it runs best on local storage, right? Direct attached storage, because nothing moves data faster between the drives and the network, or back again, than the actual PCI bus. Anything that gets between the processing, the application, MinIO in this case, and those disks slows things down. So Fiber Channel slows it down, SAN slows it down, NAS slows it down, NFS becomes unstable, which causes MinIO to go out and check the integrity of the data, thus slowing it down. So if you want object storage, S3 compatible object storage, and you want fast throughput, MinIO is an option, and it scales with hardware, and it works best with hardware that's directly attached, drives that are directly attached. The problem becomes, in a Kubernetes environment, if you have a node that has over 100 drives, the standard CSI management components made it very difficult to manage that. And typically with a MinIO deployment, you may have 16 nodes, and each node has over 100 drives, and they're local to the server, right? Or they're in a JBOD right next to the server with a SAS connection, so they're effectively local. And you need to be able to manage those, identify them, discover them, format them, not format the wrong thing, format them, manage them, monitor them. And in that kind of deployment where you don't have a centralized application, it becomes very difficult. So to address that issue, right, we built what used to be called Direct CSI, because we used the CSI interface. But Direct CSI as a terminology is a little confusing. People didn't quite get it. So we call it DirectPV, because MinIO leverages within the Kubernetes environment persistent volumes, PVs, and claims, right? We abide by the configuration standards for storage within Kubernetes. And that's important, right? There's no secret sauce. We go through the standard interfaces so that anything that can present itself as a persistent volume can be used with a claim from MinIO. But again, if you've got over 100 drives and each present themselves as persistent volumes, how do you keep the names straight, first of all, right? How do you group them? How do you know what's hot tier, what's warm tier? How do you do that? And the tools didn't exist. So we developed Direct CSI, which became DirectPV. This is the agenda. I'm going to walk through this. I think you'll see the reasoning. Go ahead, Jonathan. So network storage has you in a headlock, and that's fun. Attached storage devices are centralized, so throughput is a challenge. They're also very expensive, right? Dedicated appliances tend to be expensive. They're high margin products. It makes more sense from a value standpoint to stuff a lot of fast drives into the instances that you're running for Kubernetes already. And this is enterprise Kubernetes, enterprise cloud. And customers have a challenge with this. Go ahead. So again, we abide by the pluggable architecture because it works, and it works pretty well. And earlier it was mentioned that that it's evolving, that it's in a bit of state of flux, and that's true. But generally, it's not the interface that is the challenge in storage. I mean, that interface does seem to work. Oh, it was also the CIVO guys mentioned they were having a problem with make nod, right? And I came from Unix development labs in Hewlett-Packard, and I think I wrote some of that code. I was thinking that as I was sitting here. But anyway, go ahead. So In a Kubernetes environment, you may use NFS, you may use NAS, you may use SAN, you may use an appliance, or you may be on the cloud. And these provide solutions for the complexity, again, of managing a large number of storage devices under a Kubernetes framework. But again, you lose the throughput of the PCI connection direct to locally attached storage. And that's what we were trying to bridge. Go ahead. Not saying that network storage is bad, but if you have the hardware, you're standing up a private cloud, you can take advantage of that hardware by stuffing the boxes full of disks, full of NVMe, full of hard drives to build tiered storage. Good. I kind of covered these, honestly. Go ahead. All right, so story as old as time. Take back control. Again, you own the boxes, you own the disks, you take back control. Go ahead. So DirectPV is a CSI driver for direct attached storage. It can be thought of as a distributed volume manager for those. It allows you all the management capabilities and the monitoring capabilities that one would expect, but it works on much larger scale for large numbers of local drives. So discover them, format, mount, schedule, monitor across servers because it is a distributed volume manager. Again, a given MinIO deployment could be upwards of 128 nodes, right? You can't do it locally. It just doesn't make sense. So take the local PV concepts and enhance it to make it a distributed version. So once the local volume's provisioned and attached, DirectPV doesn't play a role in the I/O communication to the device. And that's important because, again, anything that gets between the processor and the disks interferes with throughput. So it's used for managing and connecting, but otherwise is no longer in that I/O flow. All reads and writes are performed directly on the volume. MinIO as a product, there's a trade-off between caching for performance and integrity of data, and MinIO always opts for integrity of data. So we turn off all caching, and we turn off caching in the kernel of the operating system all the way down to the drives. And the key here is all the reads and writes get directly to the volume for data integrity. Is it limited to object storage? Is it tied to MinIO? No. Anything that would benefit from services such as these or storage options such as these can benefit. It's an open source component, which again abides by the CSI interface, so there's no MinIO to it, nothing proprietary, and it doesn't depend on any specific hardware. And it allows you to stand up storage that competes quite favorably with SAN and NAS systems, especially in terms of throughput and cost. So the architecture. A single controller which allows you to manage the node drivers which are on each machine which has the storage. And then a UI which is integrated with kube control. Loads as a plugin using Crew like anything else to allow you to manage the storage using DirectPV. Picture looks like that. Go ahead. Right. Okay. So as I mentioned, allows you to manage local drives. MinIO runs really well with drives, disks just in the servers or just a box of disks next to it with a SAS connection or whatever high-speed connection there is available. Makes it simple. KISS. Picture. Next. Limited to MinIO? No. Is it cozy? No, it's not cozy. Cozy is an evolving standard if you're familiar with it, and MinIO code is actually the current code that's used for the implementation. We provided that code, and we're major contributors to the effort. But COSI hasn't standardized yet, and it's not really a full-fledged standard. Okay. Use cases. Well, I mean, because it enables high throughput to local storage, anything that requires high throughput to local storage is a use case that's viable for direct CSI. And if it's object storage that you're looking for, if it's S3 interface object storage, then MinIO is a reasonable product. It's a very good product. Trying not to sell it, obviously. That second bullet's kind of important, right? So MinIO provides resiliency through erasure coding. If you're unfamiliar with erasure coding, the approach is that you take an object, and the S3 interface is atomic. So all of this happens either 100% or 0. There's no intermediate or partial pieces left around. But you take the object and you shard it, and then you compute parity blocks appropriate to the shards. And then you distribute both the sharded data, but also the parity blocks in a way that allows you to lose drives and be able to recreate the data. So your resiliency is not at a RAID controller level within a physical box. It is across the entire cluster. So if you have 128 nodes and each one has 16 drives or some number of drives, you can lose individual nodes, you can lose individual drives. As long as you don't lose more than quorum, the data can all be rebuilt. Any application that provides resiliency at the application level in that way can leverage the DirectPV driver and local storage. Obviously, there is no requirement for underlying resiliency provided by a RAID controller or something else if you're doing it from the application layer down. I think next. Final thoughts. I know I blew through this. I'll have a lot of, we'll do Q&A. Attempting to manage large numbers of disks was difficult. That was the challenge we ran into when we were attempting to help customers deploy this into private clouds, on-prem Kubernetes deployments. So we built a tool because the interface works, it is good. This product allows you to discover the drives, format the drives, monitor and manage the drives, apply characteristics or tags to the drives if you want to set up hot, warm, cold tiering, for instance, and then gather only the drives that are tagged as hot, for instance. Management or grouping or gathering in that way, just to facilitate the management of the CSI components. And that's about it. Questions?
CSI drivers, it's common to have provisioning capabilities, but also there are extended capabilities like volume expansion, snapshot. Does DirectPV support snapshots?
The reason I walked over here is two of our engineers are sitting here.
As far as I know, repeat the question. No, there is no expansion. Once it's provisioned, the volume. Sorry. Can you repeat the question? Oh, it was joking around. Okay, fine. No, that as far as I know, once the volume is provisioned to your pod, is not going to be an expansion, especially for MinIO like perspective. So you are going to stick with that, but you can create more pools. But I don't know, Kanapan, if you.
Snapshot is something we might support later, but we don't have it right now. Yeah. Expansion, we won't do it. Yeah.
You mentioned about hot and cold characterization and disks, right? Data also temperature moves. So hot data can become cold. What do you do in that case?
So
And partial, especially when part of the disk becomes cold.
understood. So MinIO handles it per object and per bucket. At a bucket level, you identify a tiering policy that would allow you to tier data from hot drives, hot storage, to warm, to cold, based on policy. But the underlying system needs to know which drives.
Like if MinIO wasn't there,
Well, the tags are still available if an application knows to look for them and use them. Yeah.
Think of it as like application moving the data from hot storage to cold storage. So application is managing it.
Infrastructure to kind of seed some of that intelligence.
Yes.
So let them know which drives are hot, right? Which are the NVMe drives, which are the hard drives, without naming them individually because you've got 128.
But my point being, at some point you have to do the data movement because.
Oh yeah, the application does it. Yes.
So what I understand, but maybe I'm wrong, is DirectPV is good for any application that supports erasure coding, but
Yes.
otherwise you would not advise using DirectPV. Like I have a single Postgres attached to a single drive, you would not use DirectPV.
There isn't any downside, but there's probably no benefit either, right? I wouldn't bother using it with a single Postgres against a single drive.
Because if I use a storage network, for example, if my pod is dead or if my node is completely unusable, I can, most likely Kubernetes is going to schedule my pod in another node. Because it's an NFS drive, it will be recreated on the new node and I will not lose any data. That won't work with DirectPV, agree?
It will not. So what we recommend is replication of that data.
So yeah, you support a form of replication or erasure coding.
Yeah, so MinIO offers real-time replication, both synchronous and asynchronous, unidirectional from like prod to DR, or bidirectional between two active production sites.
What do you mean by replication? Replication between buckets or replication between different PVC?
Between the MinIO application.
Okay.
Yeah, so MinIO identifies or knows that it has another cluster it should replicate data to. On a per object basis, it's replicated. And if it's set up as synchronous, then the data has to land successfully in both before the 200 OK goes back to the client. So you're guaranteed that the data was written. But yeah, the resiliency is handled at the application level between those clusters. And the trade-off is, again, nothing moves data between the processor and the disks faster than the PCI bus. Right?
Okay, so I get that, and that's what DirectPV, your argument for it is, but that seems fairly short-sighted. With CXL 2.0, CXL switching, with silicon photonics, and all of these technologies, we're talking about network-connected, rack-scale, everything's GPUs, memory, CPUs, storage, at the same as directly attached latency. So it's a short-term problem that you're fixing.
So, but what is your point about like having to provide like PVs?
And what I'm saying is that you've solved for a problem that's got a very limited lifetime because CXL, silicon photonics, and all of those new technologies make this a non-issue because I can have rack-scale fabrics of storage and memory that talk the same as if it was connected to the PCI bus at the same latency.
So using that technology, is it possible then to provide all the PVs you need for your different applications
Yes.
without like?
It's the same as
And even
gas
like,
and sand,
but
it's
the
just
thing,
at
like
direct
the only thing I would like to understand from that is like, what if it is the disk? Let's say you have the drive mounted, and then it's going to format that for you in XFS, and then mount it, and then provide like that like drive that you require. Because the thing is, we start with like unmounted like drives, like a lot of them in different nodes, and this code is also able to look into, okay, you need from this node, and from this node, so you have 4 nodes, and then you can provision different drives from different nodes, and that's an advantage that you don't have to deal with that those constraints. But if that technology you are talking about is doing that already, that way, then for sure, we need to look at that. Yes.
I mean,
So this probably has a
Yeah.
limited lifetime because obviously as technology evolves, old problems cease to be.
Yeah.
Right? But the cost trade.
Yeah, cost is another thing.
Cost is going to be a killer.
possibly, but I mean, RDMA fabrics don't cost any more than traditional network fabrics, and CXL fabric switching is not going to cost any more than traditional fabrics. I don't know. I just don't see the latency argument for traditional storage being compelling.
You're computing latency at essentially a zero cost price.
Yeah.
And for some organizations that might be critical. So
Yeah,
I don't think it's trying to supersede what you're suggesting.
Yeah,
it's just another option.
True. Okay. Yeah, I get that.
Yeah, because if you look at vendors competing for commodity hardware, right, it's a no-margin business. That's guaranteed value. And then you get NVIDIA meat manufacturers competing, and it's a no-margin business. So you stuff the NVIDIAs in the server.
Yeah, I want to kind of piggyback a little bit on that there, because so say that future fabrics are fast, and we have like older fabrics that are slow. Right? There's still a benefit to DirectPV, right? Because what you want to do is make any disk look like a local disk for a distributed application to run on Kubernetes, right? And how can we like help you with this, right? So can DirectPV have drivers on their own to do this pre-provisioning of the drive, the disk to the server, right? Because I work for a legacy SAN vendor that you don't like, but I still see the benefit here, right? I mean, I help customers all day, like trying to make the disk look as a local disk. And how can I take my SAN system to attach to that workload to look like a local disk? Even it doesn't have to be a new one, it can be an old one as well,
Yeah.
right? Because we have like in brownfield use cases where you have like racks and racks of all 3 bars sitting there, right? They need to attach that to a modern workload, and DirectPV is the solution. And how can I make that like easier for them? So drivers for DirectPV.
That's where you're headed, huh? Yeah.
But it's also like how can DirectPV integrate into other CSI drivers that already exist, right? Because from what I understand, you just use a local drive that is visible to the server, right? The CSI logic already have all that to publish and stage the volume and all those good things, right? And how can you just say DirectPV, just leverage an existing CSI driver to make the disk look more?
Can we piggyback them? Do you know?
One thing there is that if you deploy like
Sorry.
what I know, and that might help a little bit to clarify, is that if you have, for instance, DirectPV installed already with Crew, because it goes on top of kubectl, so all you do is just having a bunch of nodes, right, in the cluster. And from there, DirectPV is going to take all the availables that are not like mounted, because we are not going to mess with the root space. And then from there, those are going to be listed in one place only with kubectl, let's say in the control plane, and you see all the different like drives available. And then you can format them. Actually, we are formatting them in XFS, which is the thing we prefer. And once they are formatted, then you can have like all the different volumes available for any pod in the cluster, and it's capable of knowing about the constraints. So let's say that your pod is going to be in node 2, then it's going to get the volumes that it requires for that pod in that node. And all you need to do is just tell which storage class you are going to use. In this case, you have to use the DirectPV storage class so that we can provision with DirectPV. So I guess that's kind of the answer, that you have to use the storage class that we are creating.
Yeah, I mean, I get CSI topology for free, right, with DirectPV, essentially.
Yes.
It's attached to that server, right? That's kind of the point. That's where I want to get.
Yeah, and it was going to make your life much easier. So you don't have to do all the PVs manually and then attach to a PVC. So it's done automatically for you, essentially. Yes.
But I mean, I'm at the stage right now where I need to pre-provision my SAN storage and present that to the server, right? When you can do that dynamically from DirectPV.
I'm not sure about SAN, to be honest. I need to double check with a guy that worked for us, but no, right now. With SAN now, I don't think we... Yeah, just local disk, yes, no SAN.
I mean, when it's attached, I mean, it could be a fiber channel one, whatever, right? I mean, it's a disk appearing on that server that DirectPV can work.
Yes, only in that scenario is what I have seen so far, yes.
So I want to have DirectPV create those steps for me.
We welcome contributions.
Don't ask me to write it.
That's not very expensive, the short answer.
I think I'm getting the hook. Getting the hook here.
Carry on. No, this is really good. And we're still waiting for the next speaker. So,
Oh, perfect. Okay, no worries.
so you're helping me out.
Since you're kind of putting a file system in a disk, right? You're losing efficiencies across nodes, across disks. Isn't that going to hurt your cost?
So we
Like for dedupe, for example, across.
so we don't dedupe.
You don't, I know, but
Yeah.
if it was another application running on a traditional network attached storage, right? It would make up some of that cost.
It could. It could. So for like VM backups, right? Deduping VM backups,
Or
you know,
even primary storage, not just like.
potentially, yeah. So the storage efficiency that we tend to see, you're putting XFS on the file on that disk. The idea being that as a user space statically linked binary, right, which is effectively what we are, that talks only to mount points, right, to your point, and talks only through the TCP/IP stack, right. It's pretty bomb-proof, right? There's no dependencies on shared object versions. There's no dependencies on kernel modules. There's no dependencies on hardware. Statically linked user space binary using mount points and TCP/IP, right? That's what it is. The erasure coding will get you typically 75% storage efficiency. You know, so on a petabyte raw, you'll get 3/4 of a petabyte ability to store. But it is on top of that XFS file system, so yeah. But, you know, complexity trade-off is kind of where that's coming in.
Yeah, and then the cost trade-offs. Like
Cost
when you put all
trade-offs.
of them together,
Yeah.
performance costs.
Yeah.
Quick question. So clearly your competitors like you a lot. Questions are flying from the competitors. And I know one of their competitors is a very popular user of MinIO, Nutanix.
Yes.
Um,
Yes. Very popular
very popular.
with our lawyers.
Of your MinIO. Maybe you can help us with like, who are actually using DirectPV to get a sense for. I see JBods making sense, right? So is this really private cloud providers who are trying to be vendor agnostic?
These are
Storage arrays?
yeah, these are our enterprise clouds. These are Tanzu. These are OpenShift. These are our Kubernetes deployments, either in colos, which is becoming a bigger and bigger thing these days, or
Equinix bare metal?
yes, Equinix bare metal with MinIO. They actually have web pages on how to install it. Or actually on-prem. I came from State Street Bank, right? We actually have data centers, right? So, that's kind of dinosaurish, but DirectPV and Kubernetes runs there, and there are a lot of old institutions that still have that stuff. So, but I mean, newer companies, it's colos, but it's effectively bare metal, right? Yeah, sorry.
So I understand the benefits of taking advantage of all the JBot that you have available. Okay, but how this DirectPV compares to other solutions, open source solutions that are doing something very similar, like is Ceph, okay, and Rook, okay. So how does compare DirectPV with Ceph and Rook?
So what I've seen, the customers who come to us who have used Rook, it's complexity and a little bit of instability in Rook. But I've not used it personally, so I can't speak to it personally. Ceph, it's manageability. It's configuration and manageability. If you know how to do it, it works. And if you don't know how to do it, it's difficult, is what we hear. But again, I've not used it personally, and I can't speak to that.